What is quotient rule? Let's assume we have a cosine function which is represented by f over z, and if our goal is to find the derivative of this cosine function, then the derivative is obtained by this rule, which is write down the function of the bottom as it is times the derivative of the top minus write down the top function as it is multiply by the derivative of the bottom function, and everything divided by the square of the bottom function. Let's try to see an example. Let's say our goal is to find the derivative of 3x squared plus 1 divided by 7x minus 3. So we have a cosine function here which is represented by 3x squared plus 1 over 7x minus 3. So we can clearly use the cosine rule here. So to find the derivative of this function by using the quotient rule, now we need to assume which one is f and which one is z. So let's assume f is 3x squared plus 1, whatever function is in the numerator or at the top. Okay, let's assume 7x minus 3 is z, or whatever function we have on the bottom, let's assume that by z. So z is 7x minus 3. So we can see now when we assume what is f, what is z on this formula, we also need to know what is f prime and what is z prime. So if we assume what is f and z, let's find what is f prime and what is z prime. That means find the derivative of f, find the derivative of z. So what is the derivative of f? What is the derivative of 3x squared? 6x, right? What is the derivative of 1? 0. But 6x plus 0 will be 6x, so derivative of 3x squared plus 1 will be 6x. Let's try to find the derivative of z. How do we get 7? Well, 7x, say if we apply the constant multiple rule, 7 is as it is, derivative of x with respect to x is 1, so 1 times 7 is 7, and derivative of 3 with respect to x, since this is constant, so derivative will be 0, so 7 minus 0 will be 7. So we have f, z, f prime, z prime. So those are the only variable we need over here to plug back in on this rule. So if that is the case, let's try to apply the quotient rule here. Okay, so this is the derivative, this is the function whose derivative we need to figure out, and we already have all the necessary information. So our goal is to just plug that information in this formula. So let's begin with the numerator. So here is z, so replace that by 7x minus 3, and replace f prime by 6x, replace f by 3x squared plus 1, replace z prime by 7, and on the denominator we need to have the square of z, and we can then square the 7x minus 3. Okay, so we can see here, so this is our z, this is your f prime, this is our f, right, on the formula, you can check that, and then this is our z prime, right? So that's on the formula, and then that's what we have obtained. Everything on the numerator, what we have over here, is divided by square of the 7x minus 3. Done. This is the derivative of this function 3x squared plus 1 divided by 7x minus 3. But this doesn't look like on the simplified form, so let's try to see if we can simplify and write down in an alternative form. Okay, so we have already, by using the quotient rule, we have already figured out the derivative. But on the numerator, I see couple of terms over here which I could distribute, like 6x can be multiplied with 7x, so that will be 42x squared, right? Minus 6x times 3 will be 18x, and the same way we can distribute here by the 7, and then we get 7 times 3x squared is 21x squared, 7 times 1 is 7. So let's distribute that, and here is minus, so let's distribute by minus 1 and remove this parenthesis over here. When we do that, negative 1 times 21x squared will be negative 21x squared, negative 1 times positive 7 will be negative 7. Here we just have the positive 1, so no problem with that, we can write down as it is. And we have the like term that we can combine. So 42x square, and then we have 21x square, right? So negative 21x square, when we combine we get 21x square, and then the rest of the others are unlike terms, so we can just carry it, and on the denominator we can just leave it like that.